Jai Hind all. Myself Amita Asthana from Ajay Kumar Garg Engineering College, Ghaziabad. Here in this video lecture, we will discuss about the subject digital system design, the one important topic that is ECL logic family. There are various logic families which we have already discussed, like transistor logic and the CMOS technology. So all these technologies are referred to as a logic families. Here we are going to discuss the ECL logic family, that is emitter coupled logic, right? So here some important points about the emitter coupled logic, that is, it is standing for the emitter coupled logic circuit, and this is one of the technology like TTL and CMOS. The output of ECL provides the OR and NOR functions only. So, and both we can take simultaneously. So, here two outputs will be there. One is OR and another one is NOR. So, both we will discuss how this particular circuit is giving the OR and NOR functionality. Next, the input is connected to the base of the transistor. This is one important point, that every input is connected to the base of the transistor, and the whole circuitry that has some major important parts. And first of these is differential input amplifier. So we are having this one. So we are having differential input amplifier as the one part. So in differential input amplifier, we have two transistors. So mainly if one transistor is on, another transistor will be off, and if another is off, then another will be on. So there are two transistors which are connected in differential arrangement, and they will behave in such a way that if one is off, then another one will be on. Okay. Next part is internal temperature and the bias networking for voltage compensation and all. That is also one important major part. And here we are having the emitter follower output. So this is another major important point about the ECL family, that it is emitter follower output. Now, the emitter output requires a pull down resistor for current flow. So it is majorly depending on the pull down resistor for the current flow. Another which is the most important part, that what is considered as logic 0 for ECL family and what is considered as logic 1 for the ECL family. So we will write here for 0, okay, for 0, logic 0, we will take minus 1.6 volt as voltage. This is major important part which we need to remember all the time. And if I talk of logic 1, then it will be 0.8 volt plus. So you can see this is not as logic 1 for plus 5 volt and more voltages above plus 5 volt, but the logic 1 starts from 0.8 volts and the logic 0 is minus 1.6 volts. So if this is the case, then we need to think that when when the transistors are in the saturation or non-saturation, like this one, yes, here one important point which we need to know is that whenever we are discussing this emitter coupled logic, the transistors are not in the saturation, okay. So this is also important, and hence the ECL family is a little more faster than other logic families. So here the transistors which we are employing in the circuit, they are not going into the saturation. So this is one. Now coming to the ECL family, let us discuss the circuit. Here we can see we are having various transistors. So in the figure, as we can see, there are so many transistors, Q1, Q2, Q3. Okay. So here the input A is being given, input B is being given in the circuit, right? And these are the inputs which we are giving, right? And this transistor Q3. Okay. So Q1, Q2 and Q3. This is making a differential kind of arrangement, right? This is a differential kind of arrangement, right? So here, as I told you, that it is a differential input amplifier. So this point we can see here Q1, Q2 and Q3 are in the differential input arrangement, right? Next. So see here, one major important point is that if Q1, Q2 is off, then Q3 will be on. If any one of the Q1 and Q2 is, off, then Q3 will be on. So in this way we will go ahead, right? Here I have taken one point M and one point L. Okay. This VCC is 0 volts, right? So this VCC 0 volt, we can consider it as a logic 1 or plus 5 volts as we can discuss, and here this is minus 5.2 volts. So here this 0 volt is comparatively much higher than this minus 5.2 volt. Okay, these are the biasing resistors which we have taken. These are the resistors, and based on the Q3 to be on and off, we will see where the current is going and which of the circuit are on and off. So everything will be depending on the Q4 transistor to be on and off, and here from the Q5, since it is an emitter follower, see here, the emitter output requires a pull down resistor as I have mentioned earlier. So the output we are taking from the Q5 for this arrangement, emitter follower output as OR. So this output is for OR, and the Q6 output is for the NOR gate. So from this particular point we are getting the output as OR. Like if we are giving A and B to be 0, 0, here it should be 0, and if 0, 0, both A, B and are logic 0, then it will be the output here at the NOR point, it will be 1. So whatever the output will be here, the reverse output we will get from the NOR output, right? Now let us analyze the circuit. Closely we will analyze the circuit. So suppose the first case A is equal to 0, B is equal to 0. A is given at the base of the Q1, B is also given at the base of the Q2. So this is off, this is off, right? Both Q1 and Q2 are off in this way. If both Q1 and Q2 are off, then Q3 will conduct, right? Then this is on. See why it is on, because see all the current that will not flow from this path, because this path is totally out of the circuit because these two are off. Now current should go to the M point and not beyond this M point. Okay. Again, what should be the next part? See, there are 2 points. Let's say current flows from here, right? Okay. So current is flowing through M and it will go to Q6. Why? Because this particular circuit is totally out of the path, because these two Q1 and Q2 have become off. So this QC will turn on and the output we are getting as logic high. So that verifies that A B is equal to 0, B is equal to 0. The NOR output is of course 1 or high, right? Next. Okay. Again, this is on, this part is okay. Now, some current is flowing through this, but some current will flow also through this one. Okay, through this one. Now, since this is on, okay, this is on, and here we can see that what should be the status of this Q4, because Q3 is already on. Now we need to take the output from here. See, again we will start thinking about the position of this Q4 and Q3. So for A is equal to 0 and B is equal to 0, all the inputs here, all the inputs are at logic low, and if the inputs are at logic low, then transistor Q1 and Q2 are turned off and Q3 is conducting. That we have seen. But what about the point L? Okay, what about the point L? The potential here is low and it is going to apply to the Q5 point, right? The potential at the L point is low because Q6 was on and the potential at L point is low, and since the potential at L point is low, that making this Q5 to be off. If the Q5 is off, the output of the OR gate is at logic 0, right? So this, due to the less potential at L point, the output for the Q5 is low. So A is equal to 0, B is equal to 0, the OR output is 0. Similarly, we have already discussed about the point M, that is making the Q6 to be on, and if it is on, the NOR will be at logic 1. So this is a simple technique by which we can analyze the circuit. Now, understanding few more points, we can take another case for inputs A and B to be 0, 1 or 1, 0 or 1, 1. Okay. So let us take an example for A is equal to 0, B is equal to 0, A is equal to 0, B is equal to 1, A is equal to 1, B is equal to 0. So the corresponding transistor is turned on and Q3 is turned off. See, any one of the Q1 and Q2 is on, the Q3 will get off. If Q3 is off, see, all the cases are A is equal to 1, B is equal to 1. See here, all three remaining cases. This was a 0 0. Now all these three remaining cases will be 1 1 0 1 or 1 0. So if any one of the inputs of A and B are 1, this Q3 will obviously off, right? Now what is happening when Q3 is off? Q3 is off, this particular part is out of the circuit and this is conducting. The current will of course flow from this to this. So therefore Q3 is cut off, and when the Q3 is cut off, voltage at the resistor R2 flows into the base of Q5, and Q5, if Q5 is going in the base, that will turn on and this will make OR to be 1, right? Similarly, at the same point, the voltage applied at the M point will be low, because in the earlier the L point was at low potential and here the L point is at high potential and M point is at low potential. If M point is at low potential, that will make QC to turned on, it will be on, and this will give the output as equal to 1. So this L is the at the same point the M is the low voltage is applied to the base of the transistor Q6, and if Q6 is applied, and that will be turning, if the base of the Q6 is, it is getting the current, and then it will get the circuit to be on, and 1 0 for all the outputs, this is going to be 0. Sorry, this Q5 is on, this is off, and this will give the circuit to be as 0. So here let us repeat this particular portion once more. Just a second. This is, let's say, 0 1 1 0 or 1 1. Here it is wrongly written. So there are three cases. This one of these is on, then it will be off. Okay. If this is off, then all the current will flow through this one. So the current, whenever this L point makes it high. If this is high, then because there will be no current from here, all the current will flow through this. This will become at the high potential, and if it is at high potential, this will give OR as 1, right? Similarly, reverse will take place at this M, right? And it will be at low potential, and when it is at low potential, this will give as 0. So this is the explanation of the circuit for ECL. So there are two cases, 0 0. Only in one case this is on. Otherwise, for all the three remaining cases, this Q3 will be off, and here due to just because of this Q3 to be off, this will get at the high potential, and if it is at high potential, this output will be 1, and the L and M, these 2 points are reverse of each other in every case. As in the previous case, this L was at low potential and this was at high potential. But in this case, if it was at high potential, we were getting here as 1. This was at low potential, we were getting as 0. But here in this case, this is at high potential. If it is at high potential, we are getting it as 1. And if it is at low potential, we are getting here as 0. So this is how the circuit works for ECL. Now characteristics of ECL family, the fast switching, I told you, because the transistors are not going into the saturation, and based on the bipolar transistor, the problem of transistor going to saturation, that can be stopped. So fast operation is there, propagation delay is 1 nanosecond or very less, and high power consumption. This is a drawback kind of thing, and low noise immunity, and used in some high speed specialist applications, but now they can be replaced by high speed CMOS. Thank you.